show you today. So very simple example, two of the most important kinds of change points that will define different regimes will be, for example, changes in mean. So over here we have the change in mean, where we see this sort of process take a shift downwards. And then you can have something like a change in the structure, like volatility, which happens here. So these are our change points, these lines that happen at these points, those vertical lines. And in between those change points are the different regimes that we're employing. And one thing to note is the last point in the data set's always going to be a change point because it ends our last regime. And it actually becomes important when we start implementing these things in Python. So once again, for our regime switching model, we have the formula of this form. From now on, because we're talking about changes in our stochastic process in terms of change points in time, we're going to be looking at a collection of change points being the times at which our stochastic process changes to one of these submodels, and we're going to denote it as a set of tau, where it's superscripted with this I because it's switching in particular to submodel I. Okay, so we have a few different ways we can implement this into Lean. We have some of the classic models. So for example, I do believe at QuantConnect/research on GitHub, we have a nice implementation of hidden Markov models, like with Kalman filters. One thing I'll be talking about today is the pruned exact linear time model, which is used in Python's ruptures package, but ruptures currently actually isn't one of the available packages. So I make some changes and I'm able to implement it by repurposing some code from the ruptures package. There's also binary segmentation. I didn't touch binary segmentation, but it's something that could also be easily done in the same way. There's also more Bayesian type approaches. So Facebook's Profit uses a Bayesian kind of, it's a pretty complicated approach they'll use, but they use change point detection in their general model. And indeed, you could just extract the sort of submodel for change point detection and use it within Lean. So that one's actually more simple, so I won't be talking about that, but it's a nice experiment if you are interested in this kind of stuff, you want to try it out yourself. And lastly, we have volatility clustering. So these are like Garch and related approaches. So first, let's talk about the PELT. I don't really like this slide because I'm trying to fit a lot into one slide at a time. So I've included the reference in the bottom right there if you want to learn a bit more about it. Basically, the idea is we're iteratively minimizing this function, this f of tau plus this cost function of our choice, and beta, which is a penalty term. Important thing is that we're doing this in a manner that we're starting, let's say, from left to right. So we start with our smallest change point, and then at each step of the way, we have R, which is a sort of new range of permissible change points that we can choose from, because in this sense, it has to be bigger than the last change point, so tau minus 1. So it's kind of hard to underline it there. And in the end, we're going to end up with these sort of windows where we have a change point to the left and a change point to the right. And once again, these are defined for different cost functions. We can choose different cost functions however we may wish. So for example, in ruptures, two of the more popular ones is going to be the L2 cost function. This is just the least squares model. So you want to minimize least squares. This is the simplest. There's also the Gaussian process change, which is a very sort of long, it's a decently sized definition. So it's kind of, I didn't get to really include as much as I wanted to here, but the gist of it is this log of the determinant of this covariance matrix is denoting, well, it shouldn't say the covariance in points. It should have said the log determinant of the covariance in points. So let's ignore this. So with the sigma donating the covariance endpoints of the sub-windows I. So in other words, we're at some iteration currently and looking at the covariance of the points in the iterations, in the time contained in the previous iterations. So those sub-windows I. Once again, this part's kind of hard to explain in just a slide. I highly recommend, if you're more interested about the specifics of the Gaussian process change model, to look into this paper. And these are the people who developed the package ruptures. So once again, it's not included as a library by default. So I extracted some of the relevant files and made some modifications to employ it within the QC sort of cloud server. And I have it as a gist of that link there. So two caveats are that it currently only utilizes L2 and Gaussian cost functions. And type errors are possible, even if used in ways normally, that would work with ruptures, because I have to exclude some dependencies to get this to work. Most notably the ABC package. We don't have that right now in Lean, which allows for these sort of abstract classes, but I was able to remove most of the references to abstract classes, and I've got it working. So let me show you an example in Lean. I have a notebook. Let's see if we can get it open here. All right, so here's a notebook. So Pelt is pelt.py. It's my sort of repurposed code. And once again, currently I have it such that you can choose two different cost functions. You can have your cost function set to, the normal process change, or you can have it set to L2. So from Pelt, we import Pelt. We have to import numpy, and for plotting, let's import pyplot. So just to show this example, I'm using AG, which is the US aggregate bond ETF, to show actually how we can detect change points in our current market sort of environment. So here we take the history of that AGG, take it over 2 years, or two trading, 252 days, denoting 252 trading days. From there, I had algo 1, algo 2. First one is going to be normal. Oh, sorry, the first one's going to be L2. Second one's going to be the normal one. So, oh, wow. I thought it would actually render the results. It seems to have lost the results, but that's fine, actually, because I actually have that saved here. One sec. My apologies. Yeah, I wasn't expecting that. Okay, so the results are actually saved in this. Good thing I had that. Yeah, just because I didn't want to run it now, it can take a little long. So let me just quickly fix something here. My apologies. I didn't expect that to happen. So yeah, now we have the results here. So in this case, you get to set the beta. In this case, it's going to be called pen. It's the penalty. The higher the penalty, the less points you're going to get out of this. In this case, I set it to 500 each for this first one. And we end up with two plots like this. This first one is for the L2. The second one's for normal. You can see they kind of agree over here. We have a change point. Once again, the last point's always a change point, but they'll disagree, or they'll choose different windows for this area here. In this case, we have one extra window here. That's quite interesting because, the thing is, on the bottom, we're incorporating variance into the picture. At the top, we're just looking at mean changes. So if we incorporate variance, we have a larger sort of window where everything's a bit more similar, or at least the Pelt algorithm judges it to be more similar within this range. So another interesting approach would be, what if we take the log difference of the series? We would expect the first approach, so the L2 approach, to not give us any change points. Why is that? Because we should expect our returns to be centered around 0. And then we should expect our second approach, the L2 approach, to give us some change points if there's change in just variance. And so just to test that out, I did the same thing. So I did this all with a log difference series. And exactly what we would have expected came out here. We can actually see it outlined quite nicely, the crash that we experienced in March. And since then and before then, we had a different regime in place. I didn't set it to expect a certain amount of regime. So you could set this, for example, to say, I want a set amount of change points, and it can work around that. But I had it non-constrained in this case, so it could choose as many change points as it so wished within my penalty functions. So within my penalties that I specified. So one sec. I'll bring this back to the slides. My apologies. Once again, I wasn't expecting that sort of weird thing to happen with the notebook. Okay, so that's the Pelt algorithm. Next, we have sort of Garch-based regime switching. This is also another very interesting, and I should mention the reason why I'm focusing on these models in particular is because during a time like now, sometimes I'll see people say things like, oh, I had a model that worked very well in a different type of different type of economy, like the economy before our crash. Well, that was a different regime. You could switch between two different regimes. So if it worked before, you choose what works there. If it works after, you choose what works after. You could switch between them using regime switching models. In this case, a Garch could also be used to specify changes, because it's sort of a way of detecting volatility, or it's a good way, it's able to visualize volatility as a result of this HT function. HT is called the conditional variance process, and HT, so that process is what gives Garch its signature ability to detect these shocks in a time series. So specifically, the kind of switching model that's most typically used with Garch is called an MRS Garch, which is the Markov regime switching Garch. And once again, we see that notation back in here again with the I's and the superscript. It's, in other words, merely a Garch, but the constants will now change based upon what regime we're currently at. And the shocks are sort of what incorporate our into our ability to detect changes in the volatility of the market. So there's a bit of a caveat. Oh, did someone say something? Oh. All right, so this is the last slide. Sorry, are you saying something?
Hello? No, my bad. I forgot to mute you.
Oh, okay, sorry, my bad. Okay. Yeah, so we currently don't have a nice way to implement the Markov regime switching model in QC, but there are ways to sort of implement Garch towards like similar ends, I'd say. It wouldn't be too hard to implement, and indeed it's something I'm kind of looking at to implement this specific model within Lean, because it's rather similar to what we already have with the Arch package. It's really just changing the constants around given if we're in a particular regime or not. Estimating the parameters really just comes down to fitting a simple log likelihood type of thing with I believe with analytical sort of equations for each constant, or if not analytical, I do at least recall that it wasn't too hard to fit these sort of parameters. But so that particular model we currently can't implement within Lean out of the box. You'd have to program it, but we can implement general Garch models in Lean towards visualizing if we've recently hit a shock or if we're about to hit a shock. Because a nice thing about Garch being a time series so that you can predict ahead. And let's see now if this other notebook I have is working. If that's the case, I'll be very happy. Oh, no, it's still running. Yeah, this one I should have done the same thing with. Let's see if it's able to run everything as I explain. That'd be nice if it finishes. Okay, so in this case, I'm utilizing what's called a GJR Garch, my apologies. And the rationale behind using this over a regular Garch is that I believe it's something twice the effect of it's more affected by negative shocks than positive shocks. Regardless, it's usually recommended over Garch, general Garch models for situations like the one we're currently in. So I decided to implement that one, but changing it to a regular Garch, for example, is just as easy as changing this O to a 0. That's a regular Garch. 1 is GGR, so this is easily modifiable to make it a Garch as opposed to GGR Garch. What this does is it will predict ahead one value, the variance of the process. I have it set right now such that it can do rolling. So you could set like a rolling period. So for example, you can make it'll put out a list. So I call it roll list here. Within this list are a bunch of one-step ahead predictions in a row. So it'll predict ahead, and next day it'll take that day's true value and it'll predict ahead another day. And you can plot that out as a series. Unfortunately, I don't think it's going to want to plot right now because I don't have enough computing strength, it seems. But let's see if I can show you a picture from the Arch package of how they do something very similar. It would put out a picture pretty similar to, let's see if I can find it, volatility forecasting. Let's see, they usually have some pictures here. Yeah, it'll put something out like this. So plots sort of similar to this, where it'll show the one-step predictions over time. And you'll see this kind of plot, for example, when people are plotting value at risk with Garch. And that's another way you could implement this. But the main thing is you can very easily see when there's a shock because, the next day there's a giant spike. So that's, even without the Markov regime switching models, it's kind of easy to see when you're about to hit, or when you're at a, when you're in a very volatile time or very volatile market because your next day ahead all of a sudden is higher than it's been for the past few years, there's probably something wrong. Or in this case, months, my apologies. So yeah, it doesn't seem to want to work right now. I have gotten it working. So this is one other option. I'll put this also in the gist. And yeah, hopefully I can get that fully Markov regime switching model working sometime soon. But for now, that's kind of the best out of the box thing we have. And it works to the extent that you can quite easily see if there's a sudden abrupt change in the market. So yeah, that's the presentation I have today for you guys. If you have any questions, feel free to let me know. I can do that now. Like, take questions from you. Feel free to write in the chat or, go on the mic. But yeah, that's sort of the presentation I have for you today. I'll also post the slides on that same gist if it allows me.
Anybody have any questions for Aaron?
How accurate is the regime change filter? So for the Kalman filter, I didn't test anything with that, but I do believe that, if I'm not mistaken, it might have been Jason posted something a little while back that did it. It was a very nice example about how to implement Kalman filters, and from what I could tell, it is accurate. I'm not sure I haven't looked into anything comparing it to, for example, the Pelt method or Garch, but it is commonly used in the field. And I imagine there'd probably be some research out there looking into that. But yeah, the main thing about these kind of models is if you have something that works in a different kind of economy, and you know, right now we're in a different one, you can kind of choose what works given the conditions you're in. So no need to worry about, or there is always a need to worry, but you can sleep a bit easier with your riskier procedure that worked before by changing it when it doesn't work anymore. And of course, one way of doing that would also be the Kalman filters. I'm not sure how well it reacts to variance. I do focus a lot on variance. And that's why I'd use, for example, Garch or the the normal variant of the PELT in my own work. But structural changes in terms of the mean, like I showed before, if you're looking at a log return series, you don't really expect to see anything change because you expect it to be centered around 0. So for me, volatility is kind of the main thing I focus on. Any other questions? Like I said, I could post this all online. Otherwise, I guess we can carry on. So I'll give a link to the gist in the chat, and if anyone wants to see, they can go check it out later. And feel free to email me, anything like that.
Also, most of us can be found in Slack. If you have any questions, Martin's in Slack, who previously presented, and so is Aaron, I know. So you can always ask questions there if you think of something later. But if there's no more questions for Aaron, does anybody want to kind of volunteer to show what they're working on, or if you have any problems that you're facing, maybe the people in this group could help you out. Kind of open mic at this point. Feel free to present what you're working on if you would like to.
Thanks, Aaron. Martin, those are the strategy was pretty cool, and the optimization parameter was also really cool too. I haven't really started working on the strategy yet, but a bit ago I posted on trading using Reddit stock data, and I'm currently in classes. So once I have like a little bit of a break, I'm going to start creating something that can actually work during live trading. So it's going to pull Reddit data every morning and store it into like a Google Drive folder and update it, and then the algorithm's just going to download it every morning. But also including cross-validation. So StockTwits has a pretty cool API. It'll be really interesting because there's a big problem on Reddit where they actually found out that hedge funds were tracking them. And so they started kind of maliciously posting, I'm buying X amount of shares of this, or I'm selling X amount of shares of that. And actually some hedge funds experience negative returns because of that. So it'll be interesting to kind of cross-validate, Wall Street bets with StockTwits, which is a bit funny, but I think it'd be an interesting strategy to bring into live trading to see how it performs. So that's just something I'm planning to be working on in the near future.
Does anyone have any questions about Jovad's strategy?
So are you thinking about using like what's it, like NLP? Is that the terminology for it? Like sort of getting the sentiment out of the out of the post. Maybe that's also it'd be interesting to see if the post is trying to pull your leg, so to speak, or if it's actually valuable information that comes from it.
Yeah, that's so far the original one only uses Vader sentiment. So it doesn't actually look into the semantics of it. It just does individual words and determines that sentiment. So like, for example, the sentiment of buy would be positive and the sentiment of sell would be negative, but it doesn't look into the semantics. So it can't tell if like the post is, false or if it's unreputable. It would be really interesting to include some sort of semantics. So it would look at the entire sentence as a whole and determine, is this person being genuine, things like that. And, to add on top of NLP, it would also, instead of actually looking at the word, you can add some sort of like credibility model to see, has this person posted in the past? How many times has this person posted? How many upvotes does this user have? So that could be another thing, including in that. Now, I haven't actually seen any semantic packages, but Vader sentiment is one that's just for individual words, which is pretty cool. But yeah, that will probably be added in. Actually, as you mentioned that, I found a package called Latent Semantic Analysis. I'll drop the link here. It's on toward data science. It's a media.
Yeah, everything's hidden behind a Medium paywall nowadays.
Yeah, I do have a subscription though. I think it's worth it.
Well, it's interesting. They seem to use, so they're using mostly things from sklearn, so that wouldn't be too hard to implement in the current framework. So I think that would work pretty good. And once again, you do have the sort of trove of information because, outside of just a post, because you have all their user history as well. So I didn't even consider that, but that's a good idea.
Yep. And the great thing about the new parallel, the new lean optimizer is that it runs in parallel. And one thing about the Reddit API, it's not like a processing power issue, but just on how fast and how many times you could request to pull from the API is quite low. So just to kind of pull this data takes a long time. So having the option to optimize this parallelly will be very powerful because, in terms of optimizing the parameter on, what type of sentiment are we going to accept for a long position, right? So let's say the output's a sentiment score of 0.8, but we're looking for something above 0.9, that threshold can be optimized. So when I was originally writing this, I spent a tremendous amount of time. I kind of overfit it a little bit by just deciding, which thresholds would work the best. But, I believe that this new tool that QuantConnect is going to be releasing is going to be, we're probably going to see a lot of pretty cool new alpha streams come out into the market. So, yeah.
Jason, did you want to talk about the strategy that you put in the chat a little bit?
Yeah, so I haven't had much time to actually like formulate a strategy yet, but there's this cool site, which is Down Detector, which basically tracks like national outages on any like tech platforms. So like, I don't know, maybe like Twitter has a giant outage and like the whole West Coast can't use Twitter for like a day. Like, I don't know, maybe something like that happens. And maybe there's some like intraday alpha you can find because of that if it's serious enough. So I haven't been able to make a strategy yet. But I mean, I guess if anyone else thinks it's interesting, go crazy. But basically, I'm assuming if you were to run everything locally, you could probably access. I sent their API docs, and you could probably just pull information from there, and then maybe find some signals or whatnot. Just an idea. But yeah, I mean, I think it's cool.
Thanks. Yeah, I just looked at it. I think it'll be really awesome for energy companies too. It seems like there's a couple on here. Recently with all like I've been in California, they had to shut off power for like, I believe it was like a couple days, because there was going to be a wildfire of some sort. It would be very interesting to see, the lag time between the actual, on Down Detector, the outage of, let's say, the energy, energy consumption or whatever the generators are in California or wherever it is, and price reflection in the market. So I think this would be pretty powerful for that too. But I don't know how quick it is.
Yeah, once I have free time, I guess probably winter break because courses right now. But I'll probably create an algorithm and post in the community. But if anyone's interested in like working on it or whatnot, I'm available on the Slack. So just let me know.
Does anybody else want to share their strategy? Or in our last meetup, we kind of roundtabled where everybody started in their trading kind of career interest. We wanted, the point of these meetings is to kind of build a community together where, you feel comfortable reaching out to the people you've been connecting with. Would anybody like to introduce themselves or, share where they started in trading or, their background or anything like that?
Yeah, my name is Mark, and this is my first meeting with you guys. And I have an interest in learning, quant trading. And I'm just a total beginner. I've read some web pages and some articles, and I've been trading stocks for about 10 years. I'm just interested in, learning and maybe even, finding a mentor to help guide me along.
Anybody have any helpful advice for Mark? Maybe our community forum is a really good place to start if you get stuck with anything, or we have a lot of tutorials on our website that are a really good place to start to get you, starting with algorithm building.
That sounds great. Thank you.
I want to kind of jump in here and also make a brief introduction. So this is also my first time attend this meeting here with you guys. I'm also a total beginner, so maybe Mark, we can study together. So my name is Yu Ying. I'm currently a graduate student at the University of Washington. So I'm trying to learn something about quant trading, I think. So I'm right now try to seek for some, maybe you guys can recommend some books for amateurs like me. I just went through all the tutorials on QuantConnect and get some familiarity with the kind of the implementation piece. but I think I would like to read something about how to find an alpha or something like that. How I just like can begin with a not bad strategy as a baseline.
Yeah, I did. I introduced myself last time. I'll do it again. So I'm a master's student in statistics at the University of Waterloo. I actually started in quantitative psychology, moved to statistics, and now I'm moving towards quantitative finance. So, it doesn't matter your background. I always like to say that to people, especially once I come to class and they try to use it as an excuse. But you can always learn how to do new things. That's never a problem. Before, a lot of people were talking about how to learn how to how to move in towards quantitative finance. There's kind of two ways of going at it. You can go towards it from a purely theoretical point of view, and that's kind of the way I started, where I learned, because I started from statistics, I started from probability, I learned stochastic processes, and then I kind of go downwards towards learning how to apply them. But I think that's overkill, to be honest. So for a lot of people instead, I linked a nice thing in the chat that I found. It's called QuantEcon. This does more of a bottom-up approach. So and this is what I'd recommend most people if you're starting off in the area approach this from. So sort of like immediately putting in what you learn into use in something like Python. Instead of learning the general case, start at the specific case as it applies to quantitative finance, because there's a lot of stuff which, to be frank, if you start from very theoretical, is not going to be useful for you. But something that you could immediately learn and then put what you learn into a program that you could use on QuantConnect. Learn by doing. That's probably one of the easier ways of doing it, and you tend to retain more information, especially if you learn by doing, because it's applicable. It's interesting when you can actually see and use what you're learning. So that's one link I'd recommend. There's also the tutorials, which are pretty good. I like actually one that I recommend a lot is the options tutorials on QuantConnect are very good if you haven't checked them out. But even exploring those will give you a good sort of look into how to progress in your learning experience.
Yeah, thanks. Yeah, I've already seen the free course on Udemy. So I think it's tailored for the QuantConnect bootcamp, right?
I actually don't know. I haven't been through the Udemy course, but I did kind of look at it. It seems very useful. I'll drop a link in the community forums. There's a couple posts on people asking about certain books they should read, and I think Jason also made a really good post or really good comment on some books he could read. People could read. So I think he could probably send me the link to that as well. But I'll just post one of the links I found.
Anybody else want to introduce themselves?
Okay, allow me to introduce myself. First of all, greetings to everyone, and thanks for this nice meeting. I am Assam Muhammad. Actually, at the beginning, I'm a pharmacist, but I have studied quantitative finance. I have a master in financial engineering. I have been taking a while studying how to build good algorithms in QuantConnect. I feel it's great. But for some reasons, my learning curve was not that easy because I took some time debugging my code and finding how to improve my code. But actually, currently, I am building some sort of good algorithms. What was most challenging for myself is that I have chosen type of asset that could be some sort difficult, which is Forex. Building a successful strategy in Forex is some sort of challenging in comparison to stocks or ETFs. But I found that QuantConnect is great. It's very diverse and it's very flexible. I wish I could be able to visualize my algorithm in after running it in more clear way. But I think everything is great in the platform. I'm glad to be in this meeting. Thanks for this opportunity.
Of course, we're so glad we are able to do this, especially with COVID. It's kind of, kind of an isolating time. So it's always good to connect with other people that are in the same community as you.
And also, I would like to thank you for changing this meeting time. Actually, the last time it was for me at dawn. Currently, the selection of time is much easier than the previous one. So thanks for this opportunity. Glad to be with you.
Yeah, we're, it's so hard to accommodate so many different time zones, obviously. I think our plan is to probably rotate between times just so everybody kind of has an opportunity to attend the meetings that are at a decent time for them. Like right now it's currently 11 o'clock in my time, but I know that's not the same time as everybody is. So we're definitely going to try to rotate it around so everybody gets the chance to share their ideas and be involved in the community.
That's a great initiative. I wish we are able to see in the soon as a result for these meetings, people are able, quant community are able to team up because strategy development could be much increased and accelerated if people are able to team up and share ideas and have some sort of teams in developing the strategy. This is a much successful environment than each one working on his solely on his algorithm. So this initiative is great. Thanks for doing that.
Anybody else want to share their background? We are scheduled to go until 11:30. If people want to keep sharing, if not, if we're all wrapped up, we can wrap up a little early, or it's totally up to you guys. This is a discussion for you guys. Whatever you guys want to do with it.
I do have to go because I do have to go. I have to hop on a few other meetings. It was great being at this meetup. You could find me on Slack. Just my name, Joe Iduribe. If you ever want to reach out and just talk about trading algorithms, feel free. But I do have to go. Thank you for everyone showing up. Thanks.
Yeah, I think if anybody has any last minute things they'd like to say or things they would like to present on, I'll give you the chance to do so right now. But if not, I think we'll just wrap it up. This meeting is recorded and will be on YouTube. We do these every last Thursday of the month. So before we head out, does anybody have any things they would like to talk about? Alrighty, well, thank you guys so much for joining us today. Like I said, every last Thursday of the month, these will be held. Like I said, we'll try to bounce around the time zone so everybody has an ample opportunity to be involved and get to present their ideas. But you guys have a great weekend. I hope you guys have, if you celebrate Halloween, happy Halloween. But if not, have a great weekend.